Hi, and welcome to the second video of MEDfl. In this video, we will show you how to create federated pipelines and run multiple configurations using MEDfl. To create pipelines, you have a list of nodes on the left. Each node is responsible for a specific role. You can add a node by dragging and dropping it onto the workspace on the right. Let's get started. First, we need to add the dataset node. Click on the node to specify the master dataset that will be used for training in the federated networks. There is also an input to select the target of your dataset. Next, we'll add the network node. The network node is responsible for creating the federated learning network. When you click on it, a new space will appear, and you will find two types of nodes on the left, clients and server. Let's create our network. For this example, I'll create a network with 2 clients and 1 central server. For each client, specify if it is a train, test, or hybrid client. Hybrid clients are used for both training and testing. Next, specify the dataset of the client. Once the dataset is set, you can visualize the dataset. Repeat the same process for the second client. Now, for the central server, specify the number of federated rounds and whether to activate differential privacy. If you activate differential privacy, you will need to specify 2 additional parameters, delta and epsilon. To go back to the main workspace, click on the Return button. Next, add the MEDfl setup node. For this node, you only need to provide a description. Now, we will add the federated learning dataset node. This node is responsible for creating the federated datasets based on each client's dataset. You need to specify a list of parameters, including the validation fraction, the percentage of data used for validation, and the test fraction, the percentage of data added to the test node from the train nodes. To create the model, you have 2 options: activate transfer learning or not. If you choose to activate transfer learning, you will need to choose a pre-trained model file, then select an optimizer, learning rate, and threshold. If you deactivate transfer learning, you have additional options. You can either use the custom model offered by MEDfl or create your model from scratch. If you choose the custom model, you will need to fill out some parameters manually or use the results obtained from a hyperparameter optimization node. We will cover this in another video. If you choose to create your model from scratch, you will have a code editor to write your model. Next is the FL strategy node, which specifies the central server strategy to aggregate results. There is a list of parameters to fill out, starting with the aggregation algorithms. Then, we have the validation fraction, which is the fraction of clients used for validation, and the training fraction, which is the fraction of clients used for training. The minimal used clients for evaluation is the minimum number of available clients to process the validation, and the same applies to training. Next, we have the train node, where we specify the client resources and whether to use the GPU. The last node is the Save Results node, where we can specify the file name to save our results. We will discuss saving results in detail in the next videos. Once we are done with the configuration, we can run the pipeline by clicking this node. Before running the pipeline, we can check our created configuration details and have the possibility to add more configurations. Let's add a second configuration. In this example, I want to create 2 configurations with different aggregation algorithms. To do this, add another FL strategy node and choose a different aggregation algorithm. Now we can see 2 possible paths, so the number of configurations is 2. We can check this here. As you can see, we have 2 configurations. If everything is okay, you can run the pipelines by clicking on this button. You will see a progress bar showing the progress of the execution. We have reached the end of this video. In the next video, we will see how to view the results and how to save them to files.